Thanks for coming to this. I'm Simon Ford from Blecon. We build network infrastructure using Bluetooth Low Energy. So if you're familiar with things like a LoRaWAN network or a cellular network or like the Apple AirTags network, we're building that for sort of commercial and industrial use cases. And what's quite nice is we get to talk to a lot of different customers building a lot of different things who think about different aspects of building a product and also forget to think about different aspects of building a product. So I was going to go through some of the things that we found interesting that seem to come up time and time again to act as a bit of a checklist to check that you're thinking about them and perhaps give you some ideas of how to think about them. So the way I thought I'd break this down is actually start not with software but with hardware. And look at some of the things that we've seen people battling with in this area. Then into more, I guess, the platform level operating system software, especially as we're generally talking about slightly more complicated Bluetooth Low Energy devices. So really, things like operating systems and tool chains do start to become perhaps more important than they used to be. I talk about some of the services. This is where, again, some of these devices are getting a bit more complicated, and it's important to think about services, think about the different aspects of services, and how they might impact even how you design a product or deploy a product. And then obviously the application, so different domains. This is really down to the sort of customers we tend to be working with. They're really worrying about the kind of application domain they're building. So yeah, let's start with hardware. So Bluetooth is quite an interesting technology when it comes to hardware, because for a long time, single chip solutions, when pioneers like CSR were combining the analog and the digital of radio, this has been a long time heritage of Bluetooth. So from a hardware point of view, when you think about microcontrollers or SoCs or whatever you want to call them, there's actually now a huge range of hardware that natively supports Bluetooth radios within it. It's been a long time since people have been putting down separate transceivers alongside microcontrollers. And this is the sort of spectrum of most people we talk to. They're thinking about modules, microcontrollers. They're thinking about modules. I'll talk a little bit about that. Obviously, they're thinking of devices. That's what they're building. But actually, you can think about OEM devices, things that are already available. And Bluetooth is quite interesting here. Very few people we talk to are thinking about making their own Bluetooth silicon. It does happen. People do make their own silicon. You can license that technology. It's even more risky. And to be honest, there's such a wide range of microcontrollers with Bluetooth Low Energy built in now. It's relatively rare. You're generally doing something weird or something incredibly high volume to be justifying that. So this is the sort of spectrum, and I guess as developers, when we meet people, to be honest, most of them are thinking like this, but actually through discussions it can change, and I think sometimes people should be starting more on this end and working back. But yeah, this is generally the sort of hardware that people are thinking about: single chip microcontrollers with Bluetooth built in, or the modules that they're packaged in, system in packages and things like that. So when we look at Bluetooth microcontrollers, like I said, they've been in development for many, many years now. So the technology is really quite advanced. So take a sort of a modern Bluetooth SoC, like Sam from Nordic was talking about just beforehand. This is to scale. This is a standard wafer scale package for a standard off-the-shelf microcontroller that you can buy for around £1, right? So you can see the sort of technology you get in here. I mean, if I look at this is a very powerful microcontroller. A standard ARM Cortex microcontroller running at incredible speeds, relative to if you think about the sort of microcontroller space. Huge amounts of resources. The 33 has things like trust zone in it. So actually, you have a lot of security features that were inherited from when we were developing trust zone, which actually originally was for mobile phones and DRM. That was originally where trust zone came from. So all of this technology and the radio, which is a very high-performance radio, is available in a package like that. And I think the thing we see time and time again is don't underspec your microcontroller here. The technology is so advanced and so low cost now that actually cruising DigiKey to work out which chip you're going to do based on the costs that you're finding there is not necessarily a very sensible thing. And we are, if I think about problems in projects, it's generally that the microcontroller has been underspec'd, often by the electronics engineer, not the software engineer, and things like that. Really, even now this feels like a ridiculous amount of power and performance. But if you look at how software is developing, you'll start to realize that even some people are, finding this tight when they're looking at some advanced protocols and things like that. Anyway, so Bluetooth MCUs, huge range of vendors. One of the amazing advantages of Bluetooth is there's so many vendors. It's a standard. It's been developed for lots of different use cases. So huge amount of choice. Okay, so that's obvious. And as I said, when we talk to most people in the hardware product design, they're thinking about MCUs. That's their engagement into the world. But especially if people are slightly novice, they've done microcontroller designs. A lot of design houses we speak to have come from electronics, and then electronics and firmware, and now they're getting electronics, firmware, and radio. The sort of things that are nice for Bluetooth, the RF is actually very simple. A lot of the value of what Bluetooth has done is brought as much onto the SoC as possible and made the external circuitry incredibly simple. Amazing reference designs available. So actually, the likelihood if you spin a design yourself and you know a little bit about thicknesses of traces and PCB substrates and stuff like that, you can actually probably get a design that basically works. But what we see time and time again is later on there are implications. So the design actually to get it right is hard. But actually Bluetooth is one of the easiest. So it feels accessible, and in reality it is actually quite accessible. But test is really quite hard, especially if you don't have access to facilities to do testing to understand that it really is behaving how you thought it would behave. And then certification. If you haven't gone through certification, it's worth understanding that there is a complexity to going through certification and understanding even how to drive that process. So I think the thing in your checkbox here is, have you got skills in the building, and what is the risk profile that you're willing to trade off here? So you can get some really interesting tools to help you design things. This is an example of an anechoic chamber for doing testing. So this one is actually the one that Azurio have in-house, so who's a module manufacturer. Blecon's based in Cambridge. We have Cambridge consultants opposite us. They have a really nice three-dimensional anechoic chamber. And these are the sort of things that are more used, not for certification, they're more used for testing. So is this device actually behaving how you imagine? And then certification, well, that's about getting things like the FCC certification so you understand it's within the constraints that a government will allow into their country. I don't think this is going to run as a video, but this is an incredibly mesmerizing video of this rotating round and this rotating round and basically everything rotating. So this is the sort of kit that are used by companies to characterize a device in 3 dimensions. So it's radio spectrum, and it is lovely to watch. And the scary thing is, in some of these, there's extensions where you can fit a chair, so you can put a person inside wearing a medical device and spin them round. And if you've ever been in an anechoic chamber, that's a pretty freaky experience at the best of times. But actually having one where you can sit in it and rotate it, and you get that's quite scary. But it is the sort of testing that people do. So as I say, someone like Cambridge Consultants down the road for us do a lot of medical device testing, and we've been using that chamber. This is Azurio's chamber, who are a module manufacturer, or LED, if people would come across that. Okay, so modules is the next obvious step when it comes to hardware. So what are you getting? Well, you're inheriting design and you're inheriting certification. So that, to be honest, for a lot of people we talk to, actually modules are the right building block. They seem expensive to a novice engineer because they might be double the price. But actually, it comes down to things like volume of break-even, of how much it's going to cost you, and what's the delay of your getting your product to market for cost and risk. This is probably more dominant in consumer products than other products. This is probably just generally the one that dominates in people's thinking. And this is the one where I think that people don't have naturally a gut feel for this. If it double the price for a module, feels a lot. But actually, when you do the sums, especially as Bluetooth modules are relatively cheap, $1 or $2 extra per module, you actually have to be doing a reasonable amount of volume to make that pay for itself to design something yourself. But also, what you're buying is avoiding risk. So a lot of companies actually are better off designing with a module for their first generation, and if they have the luxury of being incredibly successful in a second generation, that's when you can actually do a chip down design. You earn the right to do it. And I think that's a better approach. Think, well, I'm going to design with a module and earn the right to do a chip down, rather than I am going to hit such high volume that I need to do this. So yeah, a lot about risk understanding there. Okay, so that's modules. But there's something quite unique about Bluetooth again, which is, unlike probably a lot of other wireless standards, there's actually quite a market for OEM Bluetooth devices. So this is obviously only covers a certain category of products people are building. Things like trackers, sensors, things like this. But actually, there's a very big ecosystem of people building OEM devices based around standard Bluetooth microcontrollers that effectively you can think of as programmable hardware. So if you can find something like this that is close enough to to work for your V1, you're inheriting a whole load of things. So it's the design of the device, it's the testing and the certification, IP testing or something like that. It's actually how it's produced, the rigs that program these things, the setup of the production line. I think most people get that, but perhaps haven't thought through it enough. But one thing we see, even with people that have thought that through, is when you're building a device, you have to get the manufacturer to produce these devices, which means that it needs to be scheduled. They need to reconfigure their production line for you. So actually, if you can find a device that a manufacturer is basically already manufacturing, not only do you eliminate all the design development issues and risk and time and cost and things like that, but actually they might already be producing it. So the ability for you to order 1,000 or even 100 or even 10 units for a trial is a lot lower, whereas if they had to set up their whole production line to do your 100 units on your bespoke device, you've actually taken away some flexibility. You have to worry about cash flow. There's all these warehousing issues and things like that. So there's a lot of things that I think we tend to come across those problems more when companies are a bit further mature and they're further down their V1 and they're starting to feel some of these pains. So I think what we've found is actually a lot of companies, in retrospect, could have gone with something that was kind of off the shelf. Maybe it's a bit modified for their V1 and would have got to market a lot quicker. Would have avoided a lot of sort of cash flow and scheduling and things like that. So if you can go to some sort of device, maybe your problem can become a software problem. And this is I would say this is relatively unique to Bluetooth, that there's such a large market of these things. I think LoRa is more off-the-shelf devices, but these, in terms of things you can treat as programmable devices, is pretty interesting. Okay, so that's sort of the hardware, I guess, spectrum. If you can get to hardware, go for it. If you can work with modules, go for it. So OS and platform is a bit interesting because this has changed quite a lot over the last sort of reasonably short term, I would say, in software terms. So if you take something like the Nordic chip that Sam was talking about, actually the operating system and the tool chain is sort of dictated by the tools from the manufacturer of Zephyr as the operating system. NRF Connect is the thing that pulls it together and works for the particular chip. But this is providing you, people are not writing from spec sheets anymore. This is providing you drivers off the shelf, the operating system scheduler off the shelf. To be honest, it's impacting the tool chains So that's actually having an impact on the toolchain vendors and things like that. So I think almost everyone we speak to now are just considering this. Memory is cheap, RAM is cheap, power consumption has gone down. This can really accelerate the time it takes you to get to market, and very few people are fighting it, which was perhaps a bit more of a surprise. That we thought there would be more resistance to this sort of move, and we've seen companies that I would say when we first engaged with them, let's say a year ago, were like, no, can't change it. There's no way the software can change. Then newer chips come out. They happen to be a bit cheaper because they're on newer processes. They have more resources, and actually that story has changed even in the course of a year. So I think seriously consider what the your development tool chain looks like based on today's facts rather than perhaps history. So pretty standard. I think this is going to become pretty standard in the Bluetooth space, even though they feel like very constrained devices historically. And there's some other things that have changed. I'm using Nordic as an example here, but it doesn't have to be. But if you took perhaps how Nordic's software stack was originally put together, you had a soft device on the device. It was very innovative, actually. It's what helped make Nordic so successful. But if you look at the modern software, the breakdown is a bit different, and the separation between, let's say, in Zephyr, the host stack, or if you were using it on Linux, and the controller, it has shifted. And this seems like it's just software, but it's actually important to understand because things like this can be certified. So, for example, if you're working with the Nordic chip, you can use the Nordic controller, which is Bluetooth certified. You're using the, let's say, the Zephyr host stack, but you're not necessarily using the Zephyr controller stack. And I mean, Bluetooth is amazingly plug and play here, but it does actually have implications on things like how you can sign off products. So it's worth being aware that choices in software can have implications not just on your speed of developing software, but in things like certification. Again, I think Nordic have done quite a good job here of making this split clear. They're not dictating their controller, but actually, if you use that one, you're gonna have a good time. So software architecture actually impacting sign-off is quite interesting, and we've had people almost, so we obviously build Bluetooth services on top of these things, require us to use this to simplify certification. And then I guess the other thing in this sort of framework thing, which everyone worries about, like pretty much every customer we engage with now is thinking about this up front, which is how does bootloading work? And bootloading for two reasons. One is security. To be honest, people say that, but it's not really what they're worrying about. What they're really worrying about is how do you install firmware? How do you recover firmware? How do you avoid bricking your device? So people might wave their hands here, but really this is mostly what this sort of startup is more a requirement. But yeah, it's what they're actually looking for is how do you update a device from installation. And I mean, this is across the board. Again, I would say this is quite a transformation in the last few years for Bluetooth devices that have considered to be quite trivial. So understanding what your sort of software installation story is quite important. Okay, anyway, but that's sort of like the baseline, and then obviously what we're working on is more about services, which I think is interesting to, again, see how people are thinking about problems and where they catch themselves out later, often by shortcuts. I'm not going to talk too much about this because this is kind of what our company does. But fundamentally, a lot of what we're building is how do you allow a Bluetooth Low Energy device to communicate with cloud backends in much more of a sort of network model like you would expect from cellular. So there's loads of problems to solve. How do you flip Bluetooth around to be more a client-server architecture? How do you avoid pairing so you can do roaming and mobility? How can you use phones and laptops in the background as hotspots as well as physical hotspots? Lots of stuff. How do you balance all this network? How do you make it work great, not get in the way of users and things like that? There's a white paper and a QR code to that white paper. Go and read that. That goes through loads and loads of the sort of things that people get right and wrong here. But I wanted to talk about some other things once this is in place that really impacts how people are building products. So the first is how people are thinking about identity. And the most common identity, certainly we used to see, was it's a serial number, it's an ID, it's some sort of just number, it's a unique number, often injected or serialized in a product. But that's changed quite a lot because actually when you're thinking about security and trust, attestation and things like that, so knowing that it's the device you're talking to, suddenly some sort of cryptographic security becomes important. The natural path people take is sort of pre-shared keys, where you inject some sort of secret into a device. It's very logical. When you're development, it's a magic number in your C code, so it's, you sort of forget about it very quickly. But actually has a lot of problems in security concepts like class attacks and things like that, but also in manufacturing. It actually becomes, your trust in a manufacturing process becomes quite important. And not just your trust that you trust the manufacturer, but your trust that the manufacturer is going to get it right. Because if they don't get it right, it breaks. Is quite important. So actually what we're seeing is a lot of things where, and certainly how we've built it, so the products that we work with customers on, it ends up with like public key cryptography, which simplifies a lot of supply chain problems, avoids class key attacks, things like that. So breaking one device doesn't mean you've broken them all. Supports things like attestation, so you really know you are talking to who you're talking to, and you can hang off encryption and things like that. But yeah, so the source of identity often starts off as a magic number, which someone is going to fix in manufacturing to change to a unique number. But actually, that's quite a naive way of looking at it, and it's really worth thinking of it in terms of security, so you don't get caught up in later stages. Yeah, so the higher the security actually simplifies supply chains, which is interesting. The other for Bluetooth is location. So Bluetooth is used very widely in things like beaconing, which is very compatible with that's like a locationing system. I would say most people have historically been in this class. So if you know a device by its ID, by what it's advertising, and you can look that up in a table, you know where it is, but that assumes it's in a fixed location. A lot of beaconing actually has been built on this sort of concept where the devices move around, the hotspots are in a fixed location, and when you spot a device, you know the MAC address of the hotspot that spotted it, and you look that up in a table, and through that indirection you go, oh, well, if it's near that hotspot at which I know its location, it must be there. But actually what we're seeing a lot more now, and again, I guess what we've focused our attention on, is this last one, which is if you know if you can work out a hotspot's location, its proper location in real time, rather than in some indirect lookup, suddenly mobility becomes possible and full geolocation becomes possible, and suddenly your location hacks become very simple because location has become an actual geolocation, so you can start doing all sorts of interesting things about ring fencing, understanding where in the world it is and things like that, which regions it's in. So from a location point of view, again, going for the more complex way of doing locationing actually simplifies a lot of things. And I think this is a classic trend is, people, you're trying to simplify here, but you're not understanding the knock-on impact later. And actually, yeah, doing locationing quite fully gives you a lot of flexibility. And then the last one, which would seem obvious, but again, causes lots of problems, is around devices knowing the time. So almost all microcontrollers now have a real-time clock. And most embedded programmers will tell you that it's actually quite hard to work out how to set that clock. It often involves a UI. So what I think has often been happened is the real-time clock in the early days we used for schedulers, so for ticks of operating systems and things like that, wake-ups. You want to go to sleep and you want to wake up. That became elapsed time, so you actually have some sort of counting system that can give some concept of real time. That means relative time within a device. But as these devices get more connected, which is obviously what we're interested in, it's sort of cloud-connected Bluetooth devices, elapsed time is not actually that interesting. What's interesting is what time did something actually happen. So as data all gets back to a cloud or something like that, everything can be synchronized. So if all devices have a global concept of real time, it's much more complicated to implement that, which is why most people haven't historically done that. But the fallout of that is your whole system becomes much simpler. Because now if you log something on one device, you log something on another device, that data comes back somewhere, it's all eventually consistent. And that's such a simple but powerful concept that, again, requires a bit more complexity to implement in this sort of core services level. But then your domain logic, your application logic becomes so much simpler and so much more reliable, so much easier to debug, all that sort of stuff. So those are services that I would say don't come up as much as they should, and people think about them late. The other one, which I don't think I have been on a call with a customer in as long as I can remember where this hasn't been question number 2. Like, can you help us with over-the-air updates? So this is great because this is a real problem, and it's a real problem as software gets more complex. So Bluetooth devices have got way beyond, or a lot of them have got way beyond the point where you can just assume you've coded it correctly because it's a very simple application. So you probably need to do it, and luckily, as far as I can tell, everyone understands now they need to do it, which is great. But it can be implemented more as an exception. So I think there's I'm not thinking about it. Oh, I need it just in case. I need it as part of standard practice. There's a lot of people in the exception case at the moment. They know they need to do it because of reasons, but it's still thought of as an exception rather than part of a natural evolution of a product and a folder. So again, there's the exception one is often implemented as an out-of-band manual intervention. You have a device, someone walks up, you connect to it, you press some buttons, it injects a firmware, that's how it gets updated. That's often how that intervention exception model is often implemented. And lots of chips had bootloaders that could do this, so it was actually relatively easy to implement. But the reality is, sort of, rather than an out-of-band manual intervention, exceptional activity, luckily most people seem to be moving now to what I would consider like an in-band. It's just part of the use of the product. It happens over the channel that device is naturally communicating. It can be done automatically rather than require a manual intervention. And of course, that means you can do it as part of a fleet. So I think my last building block after the sort of more the ones that don't come up as often, but often hit people. This one comes up all the time, but I think the distinction between these two is important to make and understand that if you can get to this level of complexity to build this, a lot of your world becomes simpler. Okay, cool. We are doing good on time. So obviously, why do we know about this? Well, we're building this sort of stuff and talking to people every day about it. So we're building this cloud network that does do secure identity and bidirectional communication over Bluetooth Low Energy. It has got geolocation built in. It has got time services built in. Obviously, half of that is the network infrastructure we've built, and which includes these hotspots. So you can turn Android phones or iOS devices or Mac OS or Linux devices into hotspots for Bluetooth devices, which is pretty cool, or physical devices. And some of it is the firmware that actually runs on the devices themselves. And we have a stand down on the floor, so yeah, come and chat to us about it if you want. But yeah, it's been really nice just talking to people every day about these problems, and you realise where people are getting caught out. So this is sort of the summary of the things I've gone through, and I guess what I would consider almost like a bit of a checklist to go and make sure you're actually paying attention to these different things. They're all individually relatively simple, but often they've got taking a quick route through them or trying to shortcut some of the complexity of those individual blocks is hurting people a lot later in the production cycle, or it's hurting them in the application space. Anyway, yeah, so those are those three. And then I guess from the application point of view, well, if you fancy it, over to you. The SDK for our creating devices using those services that we do are there. So if you want to experiment with those sorts of services and how it makes you think about writing applications, even if you don't use us in your final product, it's quite liberating to have those sorts of things at your disposal and see how it changes how you develop a product. both in terms of how you write the application, but how you manufacture the product. Right, thank you. I think that's good. Yeah, this is us. We're Blecon. We're based in Cambridge in the UK, and this is us on LinkedIn if you want to see what we're up to. Thank you very much.